Assalamu alaikum.
Walaikum assalam. Can you hear me?
Yes, I can hear you.
Okay.
Recording in progress.
Can you see my screen now?
Yes, it's visible now.
Okay. Okay. So hi and welcome to the 3 days advanced course training on Google Earth Engine. I am course coordinator, and basically this is our full course content. So mainly in this course I will try to discuss all of the things one by one, and so that you can also easily understand everything. And I also try to more focus on land cover classification map. Okay, so today is our first day. Okay, and first day course content will be that first of all I also discuss about the area calculation using the Google Earth Engine platform. Okay, so in this time we discuss about that how you can easily calculate it any area means that suppose you want to calculate it the feature, different types of feature or boundary area, or how many classified area. Okay, different types of classified area, how many urban, how many built up area will be available there, you want to calculate it. Okay, so in this session I also try to discuss about this. After this I also discuss about the spectral indices and develop the skill for calculating any index. Okay, and in this time I also try to discuss all of the indices, how you can easily calculate it using the Google Earth Engine platform. Okay, then how to remove cloud from satellite imagery. Okay, and after this visualization the digital elevation model of hillshade and salt map. We can also easily use the Google Earth Engine platform for making the aspect map also. Okay, and make the NDVI chart over a period of time. I also try to discuss about this, and mainly air quality monitoring. So in this time I also try to show you this part, but next day I also try to show you the more focus on air quality monitoring, so that how we can easily get the data different time period. Okay, sulfur dioxide, carbon monoxide or other gases will available in the Sentinel-5. Okay, and first of all area calculation. In this time I also try to discuss about the how you can easily calculate the feature. So feature means that the vector data. Okay, so how you can easily calculate the vector area. Okay, suppose you want to calculate the how many area will be available for the Bangladesh country boundary. Okay, you want to calculate this. Okay, so we also try to discuss about the area calculation for features. Okay, then we also calculated the area calculation for image. In this time single image, suppose you want to calculate only for the urban area or build up area. Okay, we can also use then we can also calculate only for the one single images. Okay, single class. And then area calculation by class, all of the class, which class will be available in my land cover classification map. I also discuss, I calculated all of the things one by one. Okay, so let's start. I will open my code editor. So here you can see, here I already imported this dataset. This dataset is the Moody's land cover dataset for the whole world. Okay, and this dataset is the ready-made dataset. Okay, in this time we did not add any training point or other things. Okay, but we also cover all of the things for our next today's classes, how you can easily make the training point, how you can easily make the land cover classification map using the supervised machine learning. Okay, so in this time I just show you that how you can easily calculate the area. Okay, different types of classes or feature. Okay, So that's why I simply imported my dataset. This is called the MODIS land cover dataset, and I simply filter my date between this MODIS land cover dataset. Then I simply select this LC type 1, this band. Okay, you can get all of the information about this dataset in here. Okay, so here you can see this dataset availability date between this time period. Okay, and this dataset provider ArcGIS snippet. Okay, and you can see this is the resolution of 500 meter and all of the description about this dataset. Okay, so now I want to use this dataset for my own country boundary shapefile, and I want to calculate it all of the classes. Okay, and you can see here I use the LC type 1. So you want to check band. So here you can see LC type 1. Okay, so this description is the land cover type annual international geospheric and biosphere the program. Okay, classification, and they are classified the different types of classes. You can see LC type 1, this class table. Okay, so here you can see they are classified all of the things. Okay, total 17 feature they are classified for the whole world. Okay, but in this time I want to classify it only for my own region of Bangladesh. Okay, so for this here I already imported my dataset and filtered this dataset for my own time period. Okay, and I also show this image like this for the whole world. In this time I want to work for my own region, so that's why I need to just use here the clip function for clipping my area of interest. So for this I simply add here my boundary shapefile of Bangladesh. We can import it the boundary shapefile two way. If you want, you can simply use the asset tab, and then you can simply import it, upload your own asset. Okay, and we already covered this part. So if you want, you can also simply search here US DOS dataset. Okay, I simply use the simplified this dataset, and then I simply filter my ROI or AOI, area of interest. I simply take a variable AOI, and then I simply filter this collection table. And then I want to filter use the country name. So I simply use here this country name is Bangladesh, and then suppose I want to show this area, simply use a layer and then paste here the AOI. Okay, and I also want to focusing this shapefile. I simply use here the map center object, and then this is my AOI, and I zoom level use that 10. Okay, so you can see now my area will be imported in here, area shapefile. Okay, and in this time I just clip my whole collection. I just clip my whole collection with my area of interest. Okay, so here you can see here I already, you can see this is the classified. Okay, this is the classified. I want to show this layer, this classified. Okay, this classified, this variable stored the total whole world LULC map. Okay, so now I just the clip with my region of interest. Okay, so for this, suppose I simply use a variable. Suppose this variable name, I simply put this variable name is suppose BD LULC. Okay, then I simply call this classified variable because it stored the whole country boundary, whole world LULC map. I simply copy and then just paste. After this I simply use here the clip function. It will be clipped with my area. This is the AOI. Okay, so I simply use here the AOI. Okay, after this is my final object BD LULC. I simply copy and I want to show this result. I simply paste here. Okay, instead of classified. Okay, then click to the run. Okay, so now I can get this result only for my country boundary shapefile. Okay, so now I want to just add this image. Okay, so now I want to, you can see this is our image. Okay, if you want, you can also export this image as a TIFF format and use the ArcMap or QGIS software. And now I want to calculate it, the area. Okay, so for this I simply, first of all, I want to calculate the feature. Feature means this is my boundary area. Okay, so I want to calculate it, this feature. I also write this commenting. So calculation. Calculation of boundary area. So now I want to calculate this boundary area, and this boundary area, you can see this boundary area, this is our boundary area. So now I want to just calculate this boundary area and see how many area will be available. Okay, total area of country boundary shapefile of Bangladesh. Okay, so now I want to calculate it. So for this I simply take a variable. Suppose this variable I can simply use here the BD area. Okay, give this variable name is the BD area. Okay, so in this BD area you can see I already imported this country boundary shape file, and this country boundary shape file will be stored a variable. This variable name is AOI, area of interest. I simply copy this name AOI and then just paste here. After this I need to define it's my geometry. Okay, so that's why I simply use here the geometry. Okay, I define this is my geometry, and then I want to calculate it the area. Okay, so for this I simply use here the area function. Okay, so now when I just print this, you can see, just print this value, then click to the run. You can get this result in meter square. You can see you can get this result. This is the meter. Okay, so now I want to convert this result is the square kilometer. Okay, for the whole country boundary area of Bangladesh. Okay, so for this I simply use another variable, and in this time I simply, this variable name is that BD square kilometer. Okay, area, you can use any variable name, no problem. So in this time you can see this is my meter. Okay, this is my result of the meter square. Okay, in this time I want to convert it as a square kilometer. Okay, and this is the number. Okay, so this is the number, and this number is stored in a variable. This variable is the BD area. Okay, so when you defined any number, okay, then we use here this function called the EE dot number. Okay, so it's the function, this function is connecting with your client or your computer, the Earth Engine server. Okay, so in this time I simply use here the Earth Engine number, and which number, this number will be stored under this variable BD area. Okay, so this number will be stored in the BD area. So I simply copy and then just paste here. You can see it will be just add here. So now when I just divide with the 1 million, then I can easily get the result as a square kilometer. So I simply use here the divide function, divide, then I simply put here the 1 million, or the scientific notation is that 1e6. Okay, so now when I just print this area, BD square kilometer area, and paste here, and then I simply click to the run, you can see this is our area, and this area is now a square kilometer. Okay, 1,38,262 square kilometer area. Okay, so you can see after this, you can see if you want you can get only for the integer value. Okay, I want to need only for the integer value, so that's why you can simply use the another function, it's called the round function. So round. Okay, then click to the run, I can get only for the integer number. Okay, can see it. So mainly this is the process for calculating any vector area. Okay, in this time I can just calculate it, this area. You can see this is my country boundary shape file. I just calculated this area. Okay, whole area. So in this time, any question in here? Any question?
No, this process is understandable. But I have another type of question.
Yeah.
In the map, I have found that there are some area in the Sylhet.
Yeah.
Would you please show the classified map?
You want to show only for the Sylhet area?
Yes, please. Would you please show the classified map?
Wait, okay.
Classified one.
Okay.
Yes, sir. Okay. Yes. This one. Okay, I have found here that the Sundarban area is colored with a greenish color, and the same color is found in the Sylhet area.
Yeah. Okay.
Yes, what is this class?
Okay, we'll check this class. What is the class? Simply click on the inspector and change the pixel value. So this is the LC
Because
type
mangrove
11.
forest is.
Yeah.
Yes.
I understand. Okay, so they are also
Type
used
11.
same time of data will be available. So the 11.
Yes.
So 11 is the
Permanent
defined
wetlands.
permanent wetlands.
Permanent wetlands. Yes. Okay.
So this they are classified. The another things is that not the forest or mangrove forest. They are classified for this area for the permanent wetland. Yeah.
Yes. Yes.
Okay.
So these classes are built-in classes.
Yeah. So it's totally all of the process will be taken for the modis, and this is the totally ready-made data. And when you work with our using the supervised machine learning, then we can just use here the different types of training point for this mangrove forest and other area. Okay, but in this time here I only show you this the process of the calculating the area. Okay, so that's why they are classified here the wetland. But when you work with the our main work for the taking the training point, then you can get the different training point for the two place. Okay.
Okay. And then at that time it will be classified as in our as found in our Bangladesh. The class is found in our Bangladesh. Is it?
Yeah.
At the time we can classify as we want to.
Yeah. So in this time, then I just show you this part. So how you can just calculate it, the area and everything. Then this is the same procedure when you work with the another LULC map classification or other things. Then we can use the same procedure for calculating this area. Okay.
Okay, sir.
Okay. So this is our area. So now you can see. I just try to show you that how you can easily calculate the feature or vector area. So in this time, I want to show you that how you can easily calculate the single classes. So here you can see different types of classes will be available here. So if you want, you can see how many class will be available here. So for this, I simply print this. So bd LULC this variable, I just simply print. Okay, then to the run. So 5 properties. Okay, one band. So I simply use here the size function. You can see okay, we just when we work with the group classification, group calculated area, then we can easily get how many class will be available here. Okay, so suppose in this time you can see I want to calculate it the only for the single pixel value. Suppose you can see this is our another pixel value, gray color. I want to check what is the class. You can simply click on the inspector and simply put here. So this class is that you can see LC type 13, and I think this is our build up area. Okay, so urban and build up area. Okay, this class is classes. Okay, so now if you want only calculate it how many urban and build up lands will be available in the total whole Bangladesh country. So how you can easily then I will try to show you that area calculation for image single class. Okay, so area calculation for single class. Okay, suppose here you can see there are the lot of class will be available here, but I want to calculate it only for the area, for the build up area. I want to just calculate it. So let's start. So first of all, for this I simply take a variable and get this variable name is suppose urban. Okay, and after this I just call my whole classification. You can see this is the BD LULC. Okay, it's showing me the whole land cover classification for Bangladesh, and it stored the all of the classes. Okay, it stored all of the classes, build up area, water body or other classes it will be stored. Okay, so from this I want to select only for one class. Okay, so for this I simply just copy this variable name and then paste here. After this I simply use here the equal I just paste here my class number. Okay, so what is the class for the build up area? You can see this class number is the 13. Okay, I simply copy this and paste here. Okay, so in this time it will be showing it will be stored under this variable urban only for the pixel value for the urban and build up area. Okay, so now I want to show this result. Suppose I simply use here the map dot add layer. After this I simply call my object, and then I want to show this result as a way. Suppose I want to simply use here the mean. It will be start from the 0. It's indicating there is no build up area. Okay, I simply use the mean pixel value 0, and max it will be 1, and it's indicating there are the build up area. Okay, so it indicating the 1. So then I also use here the plated, color plated, make a list, and in this list I just use here suppose which pixel value will be 0. It's indicating there is the no build up area. I want to show this result as a gray color. Okay, I simply use here the gray, and I also want to show this area which area will be available for the build up area. I want to show this area as a red color. I simply use here the red. Okay, then
Then one will be show the urban area.
Yeah, and urban area showing the color as the red color. Okay,
Right.
and 0 there is the no pixel value for the urban or built up area, so it will be showing the gray color. Okay, and it will be and this process will be taken for the whole country boundary. Okay, so I simply click the run. Urban. also give the layer name is the argon.
Okay, then other classes are
Gray color.
shown in gray color.
Yeah. So now you can see this is the full
Yes.
map of the Bangladesh for the built up area. Okay.
Built up and urban area. Yes.
Yeah. Yes. If you want, you can also export this map as a built up area map for Bangladesh and work with any research paper or other things. Okay. So now I want
Can you
to extract.
They extract it as polygon.
Yeah, it's also possible. Okay. So we can if you want, we can just extract the built up area as a polygon or vector. It's called the raster to vector. Okay. So this is the raster format. So if you want, you can easily export this map as a vector. Okay. We can also try, if you want, I also try to show you that the next day classes. No problem. Okay.
Yes,
We can
yes.
easily export this as a vector format.
Yes. Yes, it is easy in ArcGIS, but I don't know how
Yeah,
to
yeah,
do it.
and it's also possible in the ArcGIS software. We can easily
Mhm.
use the conversation tool from raster to vector. Then it will be easily make the result. Okay.
Yeah.
So now you can see just I get my only for the urban. Suppose you want to get only for the water body or other classes. Suppose I want to work with this. Suppose cropland. I want to show only for the cropland. So you can just simply copy this number and then just paste here. Okay. I simply paste here and then click done. So now it will be showing all of the cropland as a red color. You can see
Yes.
this is all of the
Except the other areas.
yeah, and other area is the gray color. So in this time you can see, and if you want it, and this is the process for the single class calculation, how many area will be available here. Okay, and other process we also try to show you the group class. Okay, all of the class you want to calculate it, and you can see, and this is process is the same for when you are taking the training point, and we already know about that. When you just click to the training point and suppose I want to get the training point for the for this these areas, and it is the showing the as a cropland. Simply click to here, and we also try to edit proper layer properties. Okay, and when I just edit these properties, we also define that the property, and also define here there is the value. You can see we can also change the name urban or cropland or what's the class. You can just put this name, and then we also use the feature collection. Then click to the property, and property name will be same and value. Okay, suppose I want to define this value as for the cropland as the 13. Okay, then click to the OK. Then when you want to work with your training point or supervised classification, you want to just calculate it the single image classes, then you can just put here this class number. Okay, suppose you can see this is this class number. I just put it the 11 or 12 or whatever. What is the class number? Then you can simply put this class number. Okay, but in this time MODIS, this is the MODIS land cover classification, they're already defined the different types of class number for every individual feature. Okay, they already defined the class number or value. Okay, and when you work with the supervised classification, then we can just put here our value. Okay, then we can easily get this like this way, and the same, this is the same, totally same. Okay, we also work with this, no problem.
So then we could work the supervised classification by using Landsat images.
Okay,
Is it, sir?
so and
Supervised.
yeah, supervised classification, we can take the Sentinel or Landsat, whatever, all of the process will be same. And I also try to show you the both things for the Sentinel or Landsat, both satellite imagery. I also try to show you this, no problem.
Yes, sir. And for MODIS, there is no supervised classification can be conducted.
Yeah,
Okay, I just asked for my understanding.
okay.
Thank you.